Hello everyone, today we will discuss about Indian monsoon. We will understand about Indian monsoon mechanism and how it occur reversal of wind. Before understanding it, we need to understand about basic important concept. First concept is trade wind. Trade wind are the steady current of air blowing towards equatorial low pressure from northeastern and southeastern subtropical high pressure area 30° north and 30° south. This is the equatorial low pressure area. Here always low pressure exists. Then around 30° north and 30° south there is subtropical high pressure area. In between to the polar areas we have subpolar low pressure area, and near to the polar area we found high pressure because the area is very cold. We know that wind always blows from high pressure to low pressure area. So here wind will move from subtropical high pressure to equatorial low pressure. Whenever you see at the diagram, you will find this line or wind in a direction. Where does this direction come from? To understand this, we need to know about the wind's directional name. Let me show you in this figure. East, west, north, south, northeast, northwest, southeast and southwest. Now this particular wind which is blows from subtropical high pressure to equatorial low pressure, this wind is moving northeast, so we will call it northeast trade wind. In southern hemisphere, wind is moving from subtropical high pressure to equatorial low in this direction, and it is called southeasterly because the wind is blowing from southeast region. Now in this picture, India's location is very crucial for the monsoon. Generally during winter, India comes under the influence of northeasterly trade wind. But when summer comes and ITCZ shifted to north, trade wind also shifted and we comes under the influence of southeasterly trade winds and monsoon occurs. But we never say our monsoon as southeasterly. We call it southwesterly. How this become southwesterly? That is an important question. We will see it later in the video. Now what was our question is that the wind we see, we never see in a straight line. Reason behind this is Coriolis force. Coriolis force is a force which is driven by the rotation of earth, and this force is act on the wind and responsible for changing its direction. Let's understand this. Here earth is rotating in its axis. In such situation, if you throw a ball from here, rather than this ball reaching here, this ball will change its direction in this way and it will reach here. The force that changes the direction of the ball is called Coriolis force. Coriolis force also acts on the ocean currents. Now, this Coriolis force acts different direction in north and southern hemisphere. This is northern hemisphere and this is southern hemisphere. In northern hemisphere, wind deflected right side. Now, how we will know which is right or left? If you stand here, this is your right and this is your left. If you see in this direction and wind is moving in this direction, then wind will deflect in right direction. Now you are standing here and direction of wind is this, and your right would be this and left would be this. So the wind will deflect towards right. This is right side deflection of the wind in the northern hemisphere. In southern hemisphere, it is completely opposite. If you stand here, this is your right and this is your left. Wind is moving in this direction. This would deflect towards the left direction. And you are standing here. This is your right and this is your left. And wind direction is this. Here wind would deflect towards left direction. In this ways, wind are deflected. So what we have seen so far is that this wind should have come straight but it deflected right. This wind also should have come straight, but in southern hemisphere it become southeasterly wind. Otherwise it would have been southerly wind. But it is now southeasterly wind. I hope you understand this concept. Now one important concept is ITCZ, Intertropical Conversion Zone. Intertropical conversion zone is a belt of low pressure which circles the earth generally near the equator, where the trade winds of northern and southern hemisphere comes together or converge. This low pressure belt shifted with season. That means the sun is over the Tropic of Capricorn. Then ITCZ shifted to southern hemisphere because ITCZ is a low pressure belt and low pressure occurs where temperature is high. The blue line you see, this is the ITCZ of January. As soon as sun moved towards Tropic of Cancer, which means summer occurs in the northern hemisphere, then ITCZ shifted to northern side. Location of ITCZ and jet stream, that is westerly easterly, plays an important role in setting the monsoon. At the moment, we will look on the ITCZ. ITCZ passes over the Uttar Pradesh and Tibetan area. As I told you earlier, ITCZ is an intertropical conversion zone. This is the equator. From here, northeasterly trade winds is coming from northern hemisphere and southeasterly wind is coming from southern hemisphere. At one point of equator, both the winds will collide and converge each other, and air become hot due to continuous solar insolation and high temperature. The hot air will rise and here create a low pressure area. From this we understand that ITCZ is a low pressure area. Wherever it present, it will pull winds towards itself because winds always moves from high pressure to low pressure. In this way, ITCZ completes a cycle. This is a concept of Hadley cell, but our focus is in this area, that is ITCZ. Now we will focus here. This picture A showing winter in northern hemisphere. In winter, India comes under the influence of northeasterly trade wind. After reaching India, it becomes dry because this northeasterly wind already lose moisture and fall rain in the Eurasian continent. So it is a dry wind over India, but very important to note that here it is our Bay of Bengal and here it is our Tamil Nadu. When this northeasterly trade wind blows over the Bay of Bengal, which is warmer comparatively land, due to high specific heat, it attains moisture in its way and blows over Tamil Nadu and gives rain. You also might have heard in the news that Tamil Nadu gets catastrophic rain in winter. A question frequently comes in the examination that why Tamil Nadu gets rain in winter. So your answer would be northeasterly trade wind. Now coming to the summer picture, what is happening in summer is that our sun is directly over the Tropic of Cancer and ITCZ has since its place, plus our Punjab, Sutlej area, particularly here, create an extreme low pressure zone. This is a very important area. Here, as much as low pressure will occur, more it will attract air towards itself. Now what happens as soon as the ITCZ shift upward, northeasterly winds confine to this point. It is not coming any further. That is what ITCZ. This mix and converts the trade wind of the both the tropics. That means northeasterly trade wind will come to this point and southeasterly will come to this point. Now what is happening till now? This is southeasterly wind until it does not crosses the equator. This trade wind main attraction and destination point is this low pressure area, which occurs in Punjab Sutlej region. As it is a low pressure area, it pulling the winds in every possible way towards itself. As soon as it crosses the equator, it's like you are entering into another country, northern hemisphere. So you have to obey the rules and regulation of northern hemisphere. So the southeasterly wind, trade wind sends its direction to southwesterly trade wind due to Coriolis force. This is the southwesterly winds, which brings monsoon. Now, it is pertinent to mention one important point here is that tropical easterly jet stream and subtropical easterly jet stream, which plays an important role in monsoon. In winter, subtropical westerly jet stream blows over this region of India. As soon as summer begins and ITCZ comes, the subtropical westerly jet stream, this blue color line, it will shift it upward northern part of the Himalayas and the tropical easterly jet, this red color line started moving out of India. In this way, all the mechanism of monsoon gets completed. Trade winds, jet stream, particularly we will discuss in another lecture. It is a very simple concept. What are their role in bringing monsoon in India? We will take a look at that too. But at the moment, we need to see two things. Westerly jet stream move upward north Himalayas and has no rule and no impact on India, whereas tropical easterly jet streams get set. This means monsoon has almost arrived. As soon as monsoon arrived, it bifurcated into two branches. One is Arabian branch and another is Bay of Bengal branch. Here it is Arakan Mountains. Bay of Bengal branch strike these mountains and causing rainfall in northeastern part of India. From here, this branch split into two under the influence of Himalayas and low pressure of northwest India. From here, its one branch move upward along the Ganga plains, reaching as far as the Punjab plains. The other branch move up to the Brahmaputra valley in the north and northeast, causing widespread rains. Its sub-branch strike the Garo Khasi hills of Meghalaya. As a result, Mausinram, located on the crest of Khasi hills, received the highest average annual rainfall in the world. Now, Arabian branch also further divided into three branches. One branch is obstructed by Western Ghat. As a result, heavy rainfall receives side of Sahyadri and Western coastal plains. Another branch of the Arabian Sea monsoon strike the coast of North Mumbai, causing rainfall areas of central India. Thereafter, they enter the Ganga plains and mixed with the Bay of Bengal branch. A third branch of this monsoon wind strike the Saurashtra Peninsula and the Kutch. It then passes over the West Rajasthan and along the Aravallis, causing only a scanty rainfall. In Punjab and Haryana, it too joins the Bay of Bengal branch. These two branches, reinforced by each other, cause rains in the western Himalayas. And all the branches of winds try to move to fill the low pressure zone which has created here. Here it is important to know why the Tamil Nadu coast remains dry during this season. There are two factors responsible for it. First, the Tamil Nadu is situated parallel to the Bay of Bengal branch of southwest monsoon. Second, it lies in the rain shadow area of the Arabian Sea branch of the southwest monsoon. It means Western Ghats blocks maximum of southwest monsoon. So, this is about monsoon. Now you come to know about the reason or factor affecting the monsoon. They are low pressure over the North India, shift of ITCZ, rule of Himalaya, jet stream, and Indian Ocean Dipole. I have made a video on Indian Ocean Dipole which is given in the description. Also, you can see it in the I button. I hope you found this informative. That's it. Thank you. I will see you in the next video with an exciting and important topic. Till then, be happy. Jai Hind.